Okay, today we're going to be covering solving systems of equations by using substitution. Okay, so a couple things to keep in mind when we're solving systems of equations using substitution. When we're given two equations, we might end up with two equations that have different variables other than our normal x and y. And if that is the case, just understand that we treat them in alphabetical order when it comes to an ordered pair. So if we had, for instance, A's and B's, okay, A's would be our x's and B's would be our y's. But besides that, it's pretty much straightforward with both of them. First thing we want to do is try to get one of the equations that have a variable solve for itself. Second thing we'd have to do would take that value of that variable, whatever equation it is, and substitute it into the second equation and solve completely for the variable that remains to get it down to be variable equal to a number, because that'll be half of our coordinate point. Then all we have to do is take that value and plug it back into any equation to produce the second value, which will give us our ordered pair. So looking at this first example here is a little bit of an easier one because the first equation is already solved for a variable. Okay? Already y equals negative 4x plus 12. Now all we have to do is take what y equals in this case and plug it into the y value in the second equation. So if I were to rewrite this equation instead of with y having a negative 4x plus 12, we would have 2x plus a negative 4x, that'd be a minus 4x, plus a positive 12, that'd be a positive 12. And then I rewrite the rest of my equation, 2. So now we have something that we dealt with earlier on in the year. And we now need to combine like terms, get variables on one side and non-variables to the other. Variables are already on the left, so let's go ahead and leave them there. Let's get the 12 to the other side by subtracting 12 from both sides. 12's cancel out on the left, leaving us with 2x minus 4x. We'll go ahead and combine those like terms and give us a negative 2x. 2 minus 12 will give us negative 10. And finally, to get the x by itself, we need to get rid of the times negative 2 by dividing by negative 2. In which case, we'll be left with x is equal to a negative divided by negative is a positive, and 10 divided by 2 is 5. Now, our final answer is going to be an ordered pair. This is the x value, and that is always going to be the first value in our ordered pair. All we need to do now is take this x equals 5 and plug it into one of the equations up here. And since our first equation is already solved for y, because we're trying to get y equal to a number, let's go ahead and use that. So we'll use y is equal to negative 4x. We'll go ahead and plug in our y value, or our x value of 5. Then we're going to add 12 to that. So that'll give us negative 4 times 5, which is negative 20. And then negative 20 plus 12 is going to end up giving us a negative 8. And that will be our y value that we can simply plug in here. So what this means right here is if we were to graph these two lines on a coordinate grid, this would be the point where they intersect. This is the solution of this system of equations, which means this is where the values are equal at both of these linear equations. Okay? Now, once again, that's for when the variable is solved, when one of the equations is already by itself. If it's not already by itself, we have to get one of the equations to be by itself. So if you want to pause the video and try this one out on your own, you can. Okay, if we're looking at these two equations, we have 4 different variables. We could solve for any of the 4 that we have, but sometimes there might be an easier path to take. For instance, if I wanted to try to get this y by itself, I would not only have to get rid of the 3x to the other side, but then I would have to get rid of a times 5. So that might complicate a little bit. But if we look here, we have just simply an x right here. Okay? And it might be pretty easy to get just a simple x by itself. So if I take the equation x minus 2y is equal to negative 3, and to get the x by itself, all we have to do is move the negative 2y to the other side. We can move the negative 2y to the other side by adding it to both sides. 2y's will cancel out on the left, and that will leave us with x equals a value, which is what we wanted. 2y and negative 3 cannot combine with one another, so we're just going to go ahead and leave them side by side. And now what we did was we took this equation and we formed it and making it look like this one. So now we have the value of x, 2y minus 3. We are going to plug that in to the x value in the other equation. So we've already used the first equation, so now we're going to plug in this x value into the second equation. So that'll give us 3 times x, which is going to be 3 times 2y minus 3. Plus 5y is equal to 24. Now, once again, we want to get the y's by itself, so let's do the math here. We have a number on the outside set of parentheses, so we will go ahead and distribute the 3 throughout the set of parentheses. 3 times 2y is 6y. 3 times negative 3 is negative 9. And then we continue with the rest of our equation. 5y is equal to 24. All right, the y's are already on the left side, so let's leave them alone. Let's get the negative 9 to the other side by adding 9 to both sides. 9's cancel out on the left, leaving us with 6y plus 5y. Combine like terms, that'll give us 11y is equal to 24 plus 9 is 33. And then finally, to get the y by itself, get rid of the times 11 by dividing by 11 on both sides. 11's cancel out on the left, leaving us with just the y is equal to 3. That would be our y coordinate in this ordered pair, which is the second one. Now that we have y equal to 3, the question is, what equation do we plug it into? Because technically now we have two original equations and this new equation here. The trick is, you actually can plug it into any 3 of these and it will work. Okay? So once you get one equation to be solved for a variable and get an equation like this, you plug it into the second equation. But once you actually get y equal to a number or a variable equal to a number, you can plug it into whatever equation you want because it's going to come out to be the same thing for all equations. Now, it might be easiest to solve for this one since it's already solved for x. So let's go ahead and use this. X is equal to 2 times y. Well, y we just found to be equal to 3. Plug that in. We'll get x is equal to 2 times 3, which is 6. 6 minus 3, which is also 3. And that would be our answer for this one. Now, I could have plugged in 3 for y right here, and that would have given me 5 times 3, which is 15. I would have gotten a 15 to the other side by subtracting it over, and then 24 minus 15 would have given me a 9. And then we would have to get rid of a times 3 by dividing by 3, and 9 divided by 3 would give me 3. So we would have ended up with x is equal to 3 there, as well as the top one. So it does not matter which ones we would have had. Okay. All right, moving on to the notes here. Now we have two special cases here where we might end up with many or no solutions. What a no solution, we probably can understand what it looks like. It's going to look like two parallel lines if we graph them, because there would be no point of intersection. Many solutions are actually going to be the same exact equation as the one before. So let's see what happens when we end up dealing with these problems to see how similar they are. Now, just like excuse me, just like in the first problem here, where we have one of the equations is already solved for a variable, we're just going to take what that variable equals and plug it in for y. So we're going to plug negative 2x plus 5 in for y here. That's going to give us 2x plus a negative 2x, which would be minus 2x, plus a positive 5, which would be plus 5, is equal to 5. Now, we'll take a look at something here. We notice here we have 2x minus 2x. These will actually cancel out, leaving us with 5 is equal to 5. Now, since that is a true statement, that means we have many or infinite solutions. Okay? That means when we graph these lines on a coordinate grid, they're actually going to be right on top of one another because they're the exact same equation, which means there's many points where they intersect. In fact, there's an infinite number of points where they intersect. So that's why there's an infinite or many solutions for this one. So that's what it looks like when we deal with one that'll end up with many or infinite solutions. The question is, what's it going to look like when we deal with no solution? If you want to pause the video and try this out on your own, you can. All right, in this one, we have two equations. I'm just going to go ahead and do as we did before. Since neither one of them are solved for a variable, I'm just going to take the top one, x plus y is equal to negative 4, and we're going to go ahead and solve for one of these two variables. We'll solve for the x. We got to get rid of the plus y. We're going to subtract y from both sides. Y is on the left are going to cancel out, leaving us with x is equal to negative y minus 4, since those cannot combine with one another. Now we take what x equals, and we're going to plug it into the x value in the second equation. So that will give us negative y minus 4, because that was the x value, then the rest of the equation, plus y is equal to 5. Okay, so once again, we end up trying to get these variables on the left, numbers on the right, so we need to move the negative 4 to the right side by adding 4. All right, now that'll give us 5 plus 4 on the right side, that'll be a 9, but then we notice we have negative y plus y. Negative y plus y actually cancels out, so you basically end up with 0 on the left side. This right here is a false statement. So that means we have no solution, aka parallel lines. Okay? Parallel lines. All right? Okay, we do have a little bit of a word problem here, so let's see how we can do with this one. A baseball team charges $6,002.50 for season passes and $85.50 for a single admission. Last week, the team sold a combined 275 total season passes and single admissions for $171,437.50. They're wanting us to determine how many season passes and single admissions were sold. So, here's the thing. We're going to have two variables. We're going to let x equal season passes, and we're going to let y equal single admission. Now I could use whatever letters I want here. Oops, my bad. Can't spell today. Okay, we're good. Admissions. All right, we could have used, P for passes and A for admissions, but we're going to go ahead and leave it like this. Okay, so we actually have to create our two equations here. One might be a little bit easier than the other. Here's the one thing that we know. We know that they sold 275 total passes. That means however many passes they sold plus however many admissions they sold have to equal 275. That means that one of our equations is x plus y is equal to 275. Season passes plus single admissions have to equal 275. The other one's a little more complicated because we actually have to take the prices of each of them, the price of a season pass, the price of a single admission, and set it equal to the total that they made last week. So for the season passes for X, they say they sell each of those for $6,002.50. So that's going to be $6,002.5 there, times X for every season pass they sell, they are going to make $6,002.50. Now, add to that how much they charge for a single admission, which they charge $85.50 for a single admission. So per single admission that they have, they get $85.50. Now, however many season passes they sell and however many single admissions they sell, we add those, we multiply and add those together, we're going to end up with this total here, which was the $171,437.5. Okay? So we have our two little bit complicated equations here, but we're going to do the same process as we have been for the rest of these. We got to get one of these equations to have a variable by itself. It's probably going to be easiest to solve for x or y here. Let's go ahead and solve for x. So we're going to get rid of y by subtracting y from both sides. Y's cancel on the left, leaving us with x is equal to negative y plus 275. All right, so that's the value of x. We have to take what x equals and plug it into our x up here. So that means we're going to end up with 6,002.5 times our x value, which is negative y plus 275, and then the rest of our equation, plus 85.5y is equal to 171,437.5. Almost ran a little low on the right there. Okay? All right, now what we need to do is go ahead and distribute our number on the outside set of parentheses here. So we're going to go ahead and distribute that. It's going to give us negative 6,002.5y. Okay, then we have 6,002.5 times 275. That's going to give us positive 1,650,687.5. Then we have the rest of our equation still. So plus 85.5y is equal to 171,437.5. So we have something like we had before, but they're just a lot more complicated numbers. But we already have y's on one side of the equal sign, so we need to get the numbers on the other side. So I need to subtract 1,650,687.5 from both sides here. Negative 1,650,687.5. Okay, big numbers here. Those are going to cross out. We can go ahead and combine our like terms here. So if I combine negative 6,002.5 and add 85.5 to that, we end up with negative 5,917y is equal to, and then we got to do the math over here, 171,437.5 minus 1,650,687.5 we end up with negative 1,479,250. Okay? Now, big numbers here, and we'll notice we have negatives. And we start thinking, how in the world can we have negatives here when we're dealing with money and selling season passes? Well, keep in mind, we're about to get rid of a times negative 5,917 by dividing it. So we're going to divide both sides by negative 5,917, which negative divided by negative is going to give us the positive. And long room here, so we're going to move it out here. That means the y ends up, when we take negative 1,479,250 and divide it by negative 5,917, we'll get 250. Okay? So that's our y value. Okay? Now all we need to do is plug this y value in for any of the equations. Okay? Now this one's already solved for x. Let's go ahead and maybe use this one. So x is equal to negative y, so negative 250 plus 275. In which case this ends up being a lot easier because negative 250 plus 275 ends up being a total of 25 there. Now what does all this mean? 25, or X was the season passes, so they sold 70 or 25 season passes. Okay? And 250 was the Y, those were the single admissions. They sold 250 single admissions. I'm going to go ahead and abbreviate that as ADM there. Okay? Admissions. A little bit longer of a problem because we have to deal with the money values here that they were giving us, but still able to use the same process as we were on the previous examples. All right, that's going to complete the notes for this section. Make sure we're still working on the assignments, and as always, if you have any questions, send me an email.